Let's step into a chapter that sits right at the heart of responsible AI, because here we explore both what makes AI uniquely tricky and the principles we use to keep it trustworthy. Think of this as understanding the problem and the solution side by side. So here's our roadmap. First, we'll examine the characteristics that make AI genuinely different and harder to govern than ordinary technology. Things like the famous black box problem, the speed and scale at which AI operates, its heavy dependence on data, and the fact that its outputs are often probabilistic rather than certain. Once we understand those challenges clearly, we'll turn to the principles that respond to them, the pillars of responsible AI. We'll look at fairness, at safety and reliability, at privacy, and at transparency and accountability. And we'll finish with one principle that ties it all together: human centricity, the idea that AI should ultimately serve people. Here's how I want you to read this chapter. For each challenge we discuss, ask yourself, which principle helps address this? Because that's exactly how responsible AI works in practice. Principles aren't abstract ideals, they're direct answers to real problems. Keep that connection in mind, and this chapter will feel deeply logical rather than philosophical. Let's begin. Let's begin with one of the most talked about challenges in all of AI, the black box problem. It's a vivid name, so let's understand exactly what it means. Here's the idea. With many advanced AI systems, especially deep learning ones, we can see what goes in and what comes out. But the reasoning in between is incredibly hard to interpret. It's like a sealed box. You know the input and the output, but the inner workings stay hidden. Let me make this real. Imagine an AI system denies someone a loan. The applicant naturally asks, why? And the unsettling answer is that even the engineers may struggle to explain precisely which factors drove that decision. The system learned patterns so complex that no human can easily trace them. Now pause and think about that as a governance professional. How do you ensure fairness in a decision you can't fully explain? How do you defend it to a regulator or to the person affected? This is exactly why opacity is such a serious concern. Compare it to the rule-based systems we discussed earlier, where every decision could be traced like a recipe. We gained enormous power with deep learning, but we lost that easy transparency. Here's the takeaway I want you to hold on to. The black box problem isn't just a technical curiosity. It's a governance challenge that touches accountability, fairness, and trust all at once. Much of responsible AI is really about prying that box open, at least enough to explain and justify what's happening inside. Let's talk about three qualities that make AI both wonderfully useful and genuinely risky: autonomy, speed, and scale. They often travel together, so let's understand them as a trio. Start with autonomy. Many AI systems make decisions or take actions with little or no human involvement at each step. Then add speed. These systems operate far faster than any human could. And finally, scale. They can handle enormous volumes, affecting thousands or millions of cases at once. Now here's why this combination deserves real respect. On its own, each quality sounds like a benefit, and it is. But put them together, and a single mistake doesn't stay small. Let me show you. Imagine a human loan officer who holds a slight bias. They might harm a handful of applicants before someone notices and corrects them. Now imagine that same bias baked into an autonomous system running at high speed across a million applications overnight. The harm isn't a handful anymore. It's massive. And it happened before anyone could intervene. Do you feel the difference? That's the danger of autonomy, speed, and scale working together. They amplify whatever's inside the system, good or bad. So here's the governance lesson. These qualities mean we can't rely on catching problems slowly, the old human way. We need controls built in advance, monitoring that keeps pace, and the ability to hit the brakes quickly. When power moves this fast and this wide, our safeguards have to be ready before the system runs, not after. Let's focus on something so fundamental that it underpins almost every AI risk we discuss: data dependency. Modern AI lives and breathes data, and that creates a particular set of challenges. Here's the core truth. Most AI systems learn entirely from the data they are given. They have no independent knowledge of the world, only the patterns in their training data. So whatever's in that data, the good, the bad, and the flawed, shapes how the system behaves. Let me make this concrete with an example I find striking. Suppose a hospital trains an AI to predict patient risk, but the historical data mostly came from one type of patient. The system will work well for that group and poorly for everyone else, not because it's broken, but because its data was incomplete. It only knows what it was shown. Now think about quality more broadly. What if the data has errors, is outdated, or reflects past discrimination? The AI absorbs all of it faithfully and at scale. This is why you'll hear the phrase garbage in, garbage out. So here's the governance habit I want you to build. Whenever you evaluate an AI system, your very first instinct should be to ask about its data. Where did it come from? Is it accurate, complete, and representative? Is it current? Because no amount of clever engineering can rescue a system trained on poor data. Data quality isn't a technical footnote, it's often the single biggest factor in whether an AI system can be trusted. Let's explore a distinction that explains a lot of confusing AI behavior: the difference between probabilistic and deterministic outputs. Once you grasp this, a lot of things click into place. Let's start with deterministic because it's the familiar one. A deterministic system gives the same output every time for the same input. Think of a basic calculator. 2 plus 2 is always 4. No surprises, completely predictable. Most traditional software works this way. Now, probabilistic systems are different, and this is where AI often lives. Instead of one certain answer, they work in likelihoods. Ask the same AI the same question twice, and you might get slightly different responses. The system isn't broken, it's reasoning in terms of probabilities rather than certainties. Let me give you an example. A generative AI asked to write a sentence might phrase it differently each time because it's choosing among likely options, not retrieving one fixed answer. Useful for creativity, but tricky for consistency. Now think like a governance professional. If a system can give different answers to the same situation, how do you ensure fairness and reliability? How do you test it thoroughly when the output isn't fixed? This is a genuine challenge. It means we can't just check one answer and call it verified. So here's the lesson to carry forward. Because AI is often probabilistic, governance has to account for variability, testing across many cases, setting acceptable ranges, and not assuming that one correct output guarantees the next one will be. Embracing this uncertainty is part of governing AI honestly. Now we shift from challenges to solutions. And we begin with one of the most important responsible AI principles: fairness and non-discrimination. Here's the principle in plain terms. AI systems should treat people equitably and should not unjustly disadvantage individuals or groups based on characteristics like race, gender, age, or disability. Simple to state, surprisingly hard to achieve. So let's think about why it's hard. Remember how AI learns from data? If that data reflects past discrimination, the system can quietly inherit and even amplify it. Imagine a hiring tool that learned from years of decisions that favored one group. Without anyone intending harm, the system perpetuates the old bias, just faster and at scale. That's exactly what fairness aims to prevent. Here's something I want you to appreciate. Fairness isn't always obvious. There are different ways to define it, and they can even conflict. Should a system treat everyone identically or account for historical disadvantages? Reasonable people debate this, and as a governance professional, you'll often help organizations navigate these genuine tensions. Let me leave you with a practical mindset. When you assess any AI system, ask, could this disadvantage a particular group, and how would we even know? Fairness requires actively looking for hidden harm, not just assuming good intentions are enough. Because here's the heart of it. Behind fairness sits a real person who deserves not to be unjustly judged by a machine. Keeping that human in view is what makes this principle matter. Let's look at a cluster of principles that work hand in hand to keep AI trustworthy: safety, security, and reliability. They sound similar, so let me clarify each and show how they connect. Start with safety. This means an AI system shouldn't cause harm to people or the world around it. Think of an AI controlling industrial equipment or assisting a vehicle. If it behaves unexpectedly, real physical harm could follow. Safety is about preventing that. Next, security. This is about protecting the system from malicious interference. Imagine someone deliberately feeding an AI tricky inputs to fool it or trying to steal the sensitive data it was trained on. Security guards against those attacks, and reliability ties it together. It means the system performs consistently and as intended, even in messy real-world conditions, not just in the lab. Let me give you a scenario that captures all three. Picture a medical AI helping diagnose patients. It must be safe, not giving harmful recommendations. It must be secure, so no one can tamper with it. And it must be reliable, working accurately across many different patients, not just the easy cases. If any one of these fails, trust collapses. So here's the governance insight. These three principles remind us that AI must be dependable under pressure, not just impressive in a demo. When you evaluate a system, ask, is it safe if something goes wrong, secure against bad actors, and reliable in the real world? Trustworthy AI has to hold up on all three fronts at once. Let's turn to a principle that's especially close to many of you coming from a privacy background: privacy and data protection in the context of AI. Here's the principle. AI systems should respect people's privacy and handle personal data responsibly, collecting only what's needed, using it appropriately, and protecting it carefully. Now, you might think we already have privacy laws. Why is AI special? Great question. Here's the twist. AI intensifies privacy challenges in unique ways. Think about how much data these systems crave to learn effectively. That hunger can push organizations to collect more than they really need. And here's a subtler issue. AI can sometimes infer sensitive things you never directly shared. Imagine a system that from your shopping patterns guesses your health condition or pregnancy before you've told anyone. You never handed over that information, yet the system deduced it. That's a privacy concern traditional rules didn't fully anticipate. There's also the matter of data used for training. Personal information swept into a training set can be hard to fully remove later, which complicates rights like deletion. So here's the governance takeaway. With AI, privacy isn't just about guarding the data someone gives you. It's also about what the system might infer, how much it collects, and how that data lives on inside the model. As a professional, keep asking, do we really need this data? Are we using it as people would expect? And are we protecting it properly? Privacy in AI demands extra vigilance, precisely because these systems are so data hungry and so clever at inference. Let's tackle three principles that directly answer the black box problem we discussed earlier: transparency, explainability, and accountability. Watch how neatly they respond to that challenge. First, transparency. This means being open about the fact that AI is being used and how it generally works. Think of a customer being clearly told, you're interacting with an AI system, not hidden in the dark about it. Second, explainability. This goes a step further. It's the ability to explain why an AI made a particular decision in terms people can actually understand. Remember our loan applicant asking why they were denied? Explainability is what lets us give a meaningful answer rather than a shrug. And third, accountability. This is the principle that someone, a real human or organization, remains responsible for what the AI does. The machine can't be blamed and walk away. A person must own the outcome. Let me tie it together with a scenario. An AI rejects a job applicant. Transparency means the applicant knows AI was involved. Explainability means we can describe the key reasons. Accountability means a named person or team answers for it and can fix problems. See how these three close the gap that opacity opens? Here's the lesson. Together, these principles fight the natural tendency of AI to become an unaccountable black box. So, whenever you assess a system, ask, are we being open? Can we explain decisions? And is someone clearly responsible? Those three questions are the backbone of trustworthy, governable AI. Let's close this chapter with the principle that in many ways holds all the others together: human centricity. If you remember just one idea from responsible AI, let it be this one. Here's the principle: AI should ultimately serve people. It should support human well being, respect human values, and keep humans meaningfully in control, rather than sidelining them or treating them as obstacles. Let me explain why this is the anchor. It's tempting when building powerful technology to optimize for efficiency, profit, or capability and forget the people on the receiving end. Human centricity is the deliberate reminder that the human comes first. Think about a healthcare AI. A purely technical view might chase the highest accuracy score. A human-centered view asks, does this actually help patients and clinicians? Does it respect their dignity? And can a human always step in when needed? See the shift in perspective? Here's a practical expression of this principle: meaningful human oversight. We don't want AI making weighty decisions about people's lives with no human able to review or override them. The human stays in the loop, especially when stakes are high. So here's my closing thought for this chapter. Every other principle we discussed, fairness, safety, privacy, transparency, ultimately points back to this one. They all exist because AI affects human beings. So as you go through the rest of this course, keep asking the deepest governance question of all. Is this technology truly serving people? Hold on to that and you'll never lose your way.